You've definitely had this happen. You're using an LLM, maybe asking it to summarize a huge document, and it starts streaming the answer back perfectly, token by token, and then suddenly just stops mid-word.
It just freezes. And you know it hasn't crashed, but something is clearly choked up.
Exactly. And that stutter, that exact moment, is the biggest challenge in scaling these services right now.
It really is. I mean, we're kind of past the point of just bragging about raw throughput, tokens per second. The whole game has shifted to what we call Goodput.
I love that term, Goodput. It brings it right back to the user.
Well, it's the rate of requests you actually serve successfully inside your quality guarantees.
Like your time to first token and the speed of the streaming itself.
Yeah.
And to understand that freeze, we have to look at this foundational conflict happening right inside the GPU.
Think of it like a really busy restaurant kitchen. You have two completely different jobs happening at once. First, there's prefill.
That's the prompt processing.
Right. It's the heavy-duty prep work.
Oh.
Chopping vegetables, baking bread. It's super compute-intensive. And it determines how fast that first piece of food, the first token, gets to the table.
And the second job.
That's decode. That's the actual token generation. It's like plating the food or pouring coffee. It's light, it's fast, and it mostly just needs quick access to the ingredients in the fridge, the KV cache.
Okay, so a memory-bound task.
Precisely. And in most systems today, the moment a new customer places a huge, complex prefill order, that heavy prep work just takes over the whole kitchen.
It hogs the main oven, so to speak.
It hogs everything, and it blocks the fast, light decode work for everyone else. That's why your stream pauses. The big compute job starves the little memory job.
So what was the first fix? The first line of defense I saw in the sources was something called chunked prefill. How does that work?
It's a really smart workaround. Instead of trying to process that massive prompt all in one go, you just split it into smaller, manageable chunks.
Ah, so the scheduler can sneak in the faster decode steps between those chunks.
Exactly. So instead of a complete stop, it just feels like a slight slowdown. TNG Technology Consulting found that just turning this on boosted total throughput by over 50%.
50%? That's a huge gain in efficiency from your existing hardware.
It is, but you can see the limitation, right? They're still sharing the kitchen. There's still interference.
Right. It's better, but not solved, which is why the community pushed for something much more fundamental: prefill decode disaggregation.
Now we're talking about a real architectural shift. This is where we stop trying to manage the conflict and just eliminate it.
By giving them separate kitchens.
Exactly. Systems like DissServe physically separate the two phases onto different hardware pools. You have prefill workers and you have decode workers. No more direct interference.
So a big new prompt just hits the prefill pool, and the decode pool is completely untouched, so my ongoing stream stays perfectly smooth.
Rock solid and predictable, and the economic impact here is just staggering. When they tested DissServe against top systems like VLLM, the Goodput improvements were anywhere from 2 times up to nearly 4.5 times higher.
Wow.
That's not just a performance bump. That fundamentally changes whether you can run a service profitably or not.
That really is the difference between a cool demo and a scalable, cost-effective business.
It is.
For those of you navigating this complex world of AI infrastructure, whether you need help with model training, automation, or even figuring out where agents can make the biggest impact for your business, you should check out embersilk.com for all your AI needs.
Great stuff.
So physical separation with DissServe sounds like the gold standard, but it takes more hardware, right?
Yeah.
And you have overhead, like moving that KV cache around. Is there a middle ground?
There is, and it's brilliant. It's logical isolation. Systems like DuetServe use what's called dynamic GPU spatial multiplexing.
Okay, what does that mean in simple terms?
It means it partitions the inside of a single GPU. It carves out a private, protected fast lane for the decode task whenever it thinks there's going to be a traffic jam.
So it's creating walls inside one chip to protect the fast work from the heavy work.
That's it. And it can deliver up to a 1.3x throughput boost without any of the overhead of duplicating models or transferring data between GPUs. It's very elegant.
What's so fascinating is that whether you're talking about physical separation like DissServe or this logical partitioning with DuetServe, the industry is pointing in one direction. Phase isolation isn't a nice-to-have anymore. It's essential if you want a scalable, responsive, and cost-effective service that actually delivers a good user experience.
It just shows you how fast we're innovating. We're building architectures from the ground up that are designed around quality of service, not just raw power.
And when you think about it, this kind of architecture directly translates into capital efficiency.
Yeah.
You can serve 2 to 4 times more users with the same hardware, all while keeping your quality guarantees. It makes you think this won't just be an option for long. It's quickly going to become the required standard for any large-scale interactive AI. That's a huge leap for everyone. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.